Welcome everyone to today's lesson on image representation. This topic belongs to the data representation chapter on the AQA spec, and it is part of the sort of category of topics we're going to be talking about in the future, such as audio representation and text representation in computing. So this topic is all about how computers represent an actual image on your screen and how they save this to your storage in your computer. The two aspects we're going to be talking about are bit depth and resolution of the image. And these examples just give you a bit of an introduction as to what they're going to be. So these questions here, take note of them. They are just questions for you to think about while you watch the videos. Critical thinking questions for you. You don't have to answer them anyway, you don't have to submit them, but they are just good for you to keep your mind active. The two lesson targets or lesson objectives we're going to be going through are to understand what effects that should have an S there, what affects the quality of a bitmap image, and know how to calculate bitmap file sizes. So without further ado, let us begin our first slide. Now, before we get into how computers represent images, we first need to understand the nature of seeing, the nature of light, the nature of images that we see with our eyes. So just a quick science lesson for you. So light is just photons that are released by atoms when they're incredibly hot. So, the sun is one example. It is most of the light that we see here on Earth. The light that comes from the sun, that travels to Earth from the sun, is white. But if you split this white light here through some sort of crystal prism, then what you will see is that the white light will be split into all of these waveforms here, which are different colors, which basically represent different wavelengths. So for example, you have the red wave, which is very narrow in length, and you might have, or you definitely do have, the blue wave form, which is much more wider in length than the red one. Now what happens is, as this white light, which I'm going to represent with a red color here because the background is white as well, so as this light travels from the sun and hits an object here on Earth, such as a leaf, what happens is the leaf will absorb all of the different waves that make up the white light. So they will absorb all of these waves here and all of these waves over here, and they will not absorb the green wave which makes up the white light coming from the sun. Now that green wave will then be reflected from the leaf and it will travel in another direction. Now what happens is, when your eye is looking at the leaf, in the direction of the leaf, so this is your pupil here, like so, what happens is the green light enters your eye and you're able to see that green wave, which is the reason why leaves are green. The same thing would happen if, for example, the same light that is traveling from the sun, I'm just going to do a curved light here just to get it to the body of the tree, but obviously light will travel in a straight direction. I just don't want to go over the eye here. And what will happen is the body of the tree will absorb all of the waves except a brown one. So then we'll have a brown color such as this one, like so, and it will travel into the eye. And what your eye will see is the tree itself. Why? Because all of these waves that make up the light are not being absorbed, being reflected, and you're able to see those photons. Now, to use the same example, but with a digital camera, I'm just going to use my red pen here. To use the same example with a digital camera, what happens is as the light is reflected from the object, it enters the lens of the camera and is picked up by a sensor at the back of the digital camera. And what happens is this sensor, it's not the best rectangle in the world, but it'll do for this example. And what will happen is as it picks that single or that collection of photons that is coming from the leaf, it will record a green color on a bitmap being an image file on your computer. And the same thing will happen when the same light from the sun is hitting the body of the tree, reflecting a brown light here into the sensor, and somehow is being picked up by the sensor. Don't worry about the location here, this is just an example. Then it will record a brown pixel here in the image. And what will happen is as it's picking up, as it's sensing all of these photons, which are different ways, it's recording in your memory this picture that it picks up. This is how your computer is able to create an image representation of something in the real world by picking up those photons, that light which is reflecting from the object, and then basically just creating a color representation, a single picture for a collection of photons, and then a whole picture with a collection of pixels. And then of course you'll be able to see the body of the tree like so, and you're able to then see of course the leaves of the tree and the sky behind it and everything that makes up this picture. So in short, in conclusion, this is how computers are able to record and represent images. Now it doesn't have to be a camera like this one. It could be a scanner of documents, for example. So imagine this is a scanner here. What you do is you put a piece of paper here, for example, and the scanner shines a light on the paper, which reflects back into a sensor that it has down below, and it picks up, for example, all the different colors that are being reflected from the paper, and it creates an image representation of the paper that you have put in there. Maybe it has a few pictures in there and so on and so forth. So the means to record the image isn't important here. What's important is you understand that all of the devices which record images on your computer work by sensing this light that is coming through the sensors, or sort of through an input device, and the sensor is picking them up and recording all of this data in your memory, which is representing an image. Okay, next video we're going to be talking about what pixels are and what bitmap images are.